Okay, welcome to a section I know you're really going to like. You're really going to like it because if you notice, there's only 4 slides here. We just covered logarithms. You know exponents is coming after that. We did it in the same order when we did derivatives. Now, when we took the derivative of e to the some power, we rewrote it and then multiplied by the derivative of its exponent. Okay, so when we do integration, it's going to go backwards. Okay, whatever you have for your exponent, you're going to need its derivative as well. So whatever you have here, you're going to need his derivative, and when you integrate it, you get e to the u power. So for instance, when we take the derivative of e to the x, it's e to the x. So when we take the integral of e to the x, it's e to the x plus c. Okay? So when I'm looking at this, if I have a power other than x, I'm going to need to use a u substitution. That's the case in number 1. My u is going to be the power I do have, which means du needs to be 5 dx. I don't have that 5, so I'm going to put it in there. Times 5, but I can't just put numbers in, so I'm going to have to counteract that with its reciprocal, so I've just multiplied by 1. So I have 1/5 times the integral e to the u du. Well, the integral of e to the u is e to the u. Whoa, I was on heavy core e there. So 1/5 e to the u plus c. So I have 1/5 e to u, but what was u? It was 5x. Plus c. Okay, well that didn't seem so bad at all. Let's look at example 2. Same thing, I have e and I have a power that is not an x, so my power has to be my u substitution. If u is going to be x to third, du has to be 3x squared dx. I have the x squared dx, which is the hard part. I need the easy part, which is the number. I'm multiplying by 3. I can multiply by 1/3. So once again, I have not changed the value of my integral. I have e to the u. All of this, x squared dx times 3 is all du. When I integrate that, I get 1/3 e to the u plus c. Please never forget to substitute your u out of there. X to the third. Now that one's kind of hard to write because you have a power taken to power, so just make sure you make it nice, pretty, and high. So there's my final answer. Okay. So example 3, same process. E does not have an x for a power, so that's going to be our u. So du needs to be secant squared, and I have secant squared. Okay, so that becomes just plain and simple e to the u du. You integrate it, it's e to the u plus c. Substitute out your u. Derivative, I get negative 2x to the negative 3. Well, that's just negative 2 over x to the third. I have my 1 over x to the third. I need negative 2 over. So I'm going to multiply by negative 2, counteract that with a negative 1/2. So now, boy, that's a lot of red. I'm going to change it. There we go. 1/2. I have my e to the u. And then my, all of this right here is my du. Exponentials are just so nice and sweet and simple. You know when you integrate that, you're going to get e to the u, and u was 1 over x squared power. Don't forget your plus c in the simplicity and the elegance of the differentiation. Okay, let's look at our last little examples. Oh, mercy, look at what has happened. Okay, number 5. I've got all kinds of e's. So if I have more than one e, I'm probably not going to use the exponent as the u substitution. I'm going to have to go bigger. Well, when I look at this, I have a numerator and a denominator. Remember what we discussed in the last section? du can't be in the bottom, so I'm going to make that u. And we're going to take the derivative of u and see if that's what we have in the numerator. Well, the derivative of e to the x is e to the x. The derivative of e to the negative x is e to the negative x times -1. So sure enough, that's exactly what we have. So how exciting and different is it that we have du over u, which turns out to be the natural log of the absolute value of u, which is the natural log of the absolute value of e to the x plus e to the negative x plus c. I can't simplify that anymore because of the plus in there. I could go ahead and take care of that negative exponent. If you're looking at a multiple choice situation, they probably won't get rid of that negative exponent, but we can. Now our last example here, we've got more than one e, but unlike number 5, I can go ahead and divide it out. So if I divide e to the 2x by e to the 1x, I get e to the x. 2e to the x divided by e to the x is 2. And then I have 1 divided by e to the x, which is e to the negative x. Now when I look at this whole process, these guys are raring and ready to go. Okay? This guy needs a little work though. He needs a u substitution. So what I'm going to do is I'm going to separate these out. These guys are nice and pretty and ready to go. Plus, this guy needs some work. I'm going to write him in another color. Now that dx was multiplying all the terms, so I sure can split this up. It's just your addition and subtraction property. Now on this one, I'm going to need my u substitution because I need that negative x. So du is going to be negative dx. So all I needed was a -1. I call this a baby u substitution because very often you can do this u substitution in your head. You don't even have to write it down. So if you can figure out what that exponent is doing to the actual problem, you are more than welcome to just go ahead and write it down as is. For instance, on that first, where we had e to the 5x, that 5x affected us by that 1/5 in front. So if you can keep that in mind, you don't have to show the u substitution for all of it. So when I take the integral of e to the x, it's e to the x. The integral of 2 is 2x. When I take this guy's integral, I have negative e to the negative x. Everybody's got the plus c. And then, okay, I just went ahead and substituted that at the same time. So let me back up. I don't want to go too fast. So the integral of e to the u is e to the u plus c, then substitute. I don't want to substitute too fast because I really don't want to lose anybody. And then we have our negative x. If you want to change that back, you can. So that'll be 1 over e to the positive x plus c. All right, those are all of our examples for section 5-4. You now know how to integrate quite a bit. Enjoy.